So if I have this right, when we talk about the mathematical concept of category theory, we're talking about collections of objects and arrows, which, is that right?
Yeah, that's correct. So it's basically what category theory is about, is how you compose things together without worrying too much about the details of what you're actually composing. What is important is the type of composition that you choose rather than the object itself that you are composing. And that makes life a lot easier for specific problems.
So it's associative.
Associativity is one of the properties that are at the base of category theory. There are others. But yes, associativity is one of the key ones. And then you have the other key property is identity. So you need, no matter what type of composition you choose, you want it to be associative and having the identity property. So having a way of reproducing itself.
Okay. And this is something that you mentioned, the cool kids in functional programming are picking up. So how is it used in functional programming?
At the beginning, it does look weird, in particular for people like me. I mean, I was a Java developer until, let's say, 4 years ago. And at the beginning, when I started approaching this new world, it was just bonkers, to be honest with you. But after a while, you get used to it. It becomes more and more natural, and you understand how more productive and less prone to errors you are. So it definitely is a process that you need to go through, and I'm going to be honest, it's not going to be easy at the beginning, but it's definitely worth it because your code will be better.
Oh, cool.
So yeah,
it's a
that's
way
cool.
Then of organizing how you write your functions and chain them together. And
exactly. So basically you will declare the type of composition that you want, and you will gain some expertise in choosing the right type of composition for the right type of the problems that you have. And once you pick the right type of composition, obviously the process of going through stacking all your operation together is going to be much easier, and it's going to be a lot easier to have a program that doesn't have huge bugs. Obviously, bugs will always be there, but it's going to be, in theory, it's going to be easier. So you're not going to have non-pointer exceptions or exception that blow away and you didn't consider. So that makes life a lot easier.
Can you give me an example of category theory solving a simple problem?
It's something that I'm going to talk about in my talk, but it's basically the way we reason is by trying to decompose a problem that we have in smaller problems and then compose them together. So if you think about it, any to-do list in your life, like, for example, when you bake a pizza, you want to get the dough, then you want to get the sauce, and then you want to get the mozzarella. But what happens if any of these three things are not there? What happens is that you cannot make a pizza. So if you express this through types, instead of have to do this check manually and make sure that the function that gets you the dough actually has the dough, and so on and so forth, you can just combine them together, and the composition will know that if any of the ingredients is not there, the whole thing is not there. So it's just a way of analyzing your problem and composing the bits and pieces together. It's not something new. We have been doing this our whole life, not just with programming. It's just a different way of doing it.